Welcome to this MCA webinar, the Industrial Internet of Things. My name is Carrie Hitchner, and I'm the Marketing Manager for the Motion Control Association. This webinar will be recorded, and a link will be sent to you within the next 24 hours. If you have any questions, please submit them in the questions panel of your webinar screen, and we will answer all questions via email after the webinar has concluded. I'd now like to introduce our presenter for today's webinar, Kristen Lewatsky. Kristen is a contributing editor for Motion Control Online and has written about motion control and automation for more than 7 years. As a technical writer, she covers a variety of subjects ranging from memory and microelectronics to nanotechnology to lasers and photonics. Kristen previously worked as an engineer on NASA's Chandra X-ray telescope before switching to writing about technology. Kristen holds a BS in physics and a master's in optics and photonics from the University of Central Florida. I'd now like to hand it over to Kristen to begin today's presentation. Kristen, you can take it away.
All right. Thanks, Carrie, and thanks to the MCA for allowing me to present and for everybody out there on the call. I don't know if anybody's from up in New England, but we're getting inundated with snow right now, so any brave souls who are out there, good luck to you. Let's see, so let's talk about the Industrial Internet of Things. Unless you've been living under a rock, you've probably heard a lot of talk lately about the Internet of Things, and it's got some particularly exciting stuff in store for the industrial spheres. So let's take a closer look. So for a long time, connectivity when the, hold on, my screen just disappeared. Connectivity when the internet came together, that whole concept has been changing. Originally it was, how do we connect locations? We've got a static desktop somewhere in a building, and we're all connecting up to the internet, and we're linked that way. And a few years ago when the smartphone launched, that morphed into connectivity of people. So rather than places, it was, people cruising around with their smartphone, accessing the web. And now we're right at the threshold of moving to a new level, which is connecting devices. So now it's about not places, not people involved, but devices communicating among themselves and with people to perform different tasks. Next slide. Now, as far as the Internet of Things, again, probably a lot of people on this call are familiar, but I want to kind of establish a common set of definitions. Internet of Things is, just by its name, not really a thing. It's a concept. It's it uses smart components, but it is about the value of being connected, of all of these devices being able to exchange information, and people and other devices being able to access it. So it's a connectivity that's the thing. Next one, Carrie, please. And there are all kinds of big numbers floating around out there. People have very high expectations for what this can do in terms of generating revenue, and it kind of makes sense in that, when the Internet launched, it was responsible for huge revenue bumps and has been ever since. And the thinking here with the Internet of Things is that that's going to, same thing's going to be happening, especially on the industrial sphere, and it's likely going to dwarf what's happening on the consumer side. This quote here is from a paper that GE did, a white paper kind of devoted to the topic, and they're throwing around 15 trillion numbers. There are other groups. Cisco's got some projections of very large numbers as well. Something important to pay attention to. Next slide. Just to, again, get our common language, machine to machine, and so on. You'll hear about machine to machine, and that's actually been going on for a while. It's kind of like that all porpoises are dolphins, but not all dolphins are porpoises. Machine to machine is a part of the Internet of Things, but it's not the entirety of the Internet of Things. The Internet of Things encompasses that, but it's also machines communicating with people. It's people communicating with machines. It's people communicating with objects and vice versa. In fact, the guy who coined the term Internet of Things did it within the context of a report that he gave where he was saying that, this thing is coming, but right now it's very much about people inputting data into the machine. That's where machine-to-machine and Internet of Things both are kind of poised to be particularly powerful right now because it takes the need for human intervention out of the loop and allows a lot of really useful things to go on without taking time and energy and bandwidth, and also introducing any kind of latency. So some of that machine-to-machine stuff is pretty important. Next slide. And of course, you got to have the obligatory big number slides. You're going to be talking about the Internet of Things. And there are some boggling numbers out there. As you can see here, by 2020, you've got 3 different numbers. Take your pick. You've got 16 billion, you've got 25 billion, you've got 30 billion. Now, I have seen some interchanges where you've got skeptics taking the analysts to task going, come on, where are you going to come up with these numbers? And how many new devices would have to come online per person in order to meet those numbers? But part of what they're thinking in terms of with this overall general Internet of Things is, stuff like not just the smart refrigerator, but a sensor on every bag of lettuce, every carton of eggs, whatever out there, that you have multiple sensors within your phone, within your car. Each one of those counts as something. So it's not just 30 billion vehicles or 30 billion smartphones out there. The number encompasses much more. And obviously below I list a few of the types of things that are showing up in these studies. Now, part of what's going to be interesting in terms of watching this going forward is, for example, I just saw a study not long ago regarding wearables that suggested that at this point, roughly 1 in 10 young adults has some sort of an activity tracker, but it also said that of those 1 in 10, 1/2 of them are no longer using them, and 1/3, I believe it was, stopped using it within 6 months. So there is going to be uptake. There are a lot of really practical applications out there, but then there's also the novelty factor. So we'll be curious to see how well these giant projections hold up as we get closer and closer. But 2 key things that are really important as far as what it takes to make something part of the Internet of Things, whether industrial or consumer, is that you need to have embedded intelligence, you need to have connectivity so that these devices can actually be part of the Internet. Next slide, please. Now, let's take a closer look at the numbers. Up until now, I've been sort of giving you the general Internet of Things lay of the land that encompasses consumer as well as industrial. But this is some information that came from folks at IHS, and they augur into the industrial Internet side, I think, a little more cleanly. If you take a look at this data plot, the left-hand axis, vertical axis, is total installed base, and that applies to the red curve. And the right-hand side is the annual shipments, and that applies to the bar chart. And as you can see, up through industrial is starting to grow. Industrial is that teal blue that's right above the, I don't know what you would call that, chartreuse that's consumer. It's starting to grow in 2013, but by 2016, bam, industrial is out ahead. And if you watch throughout the course of that projection, industrial far and away takes over. And that's what's really interesting in terms of what's going on with this whole industrial Internet of Things. It's, it's a novelty that's got the quick uptake with the technoids out there on the consumer side. Yay, I want to have a wearable for my dog so that I can keep track of whether my dog's running around too much or not enough. But the reality is, long term, there's going to be an enormous value add in the context of industrial in terms of productivity, transparency, service, overall equipment efficiency, all that kind of stuff. Far, far, far outweighs, tracking your workout and buying a widget that you throw away in 6 months or stick in a drawer and never come out to. The industrial stuff is going to go into place. It's happening slowly, but it's got a really important role to play, and it's kind of developing off of what's technology that's already been in development for a number of years. So exciting stuff coming on there. Next slide, please. And just not to put too fine a point on it, but when we talk about industrial Internet of Things, again, it's the concept of connectivity, but it involves your smart components, your embedded sensors, your ability to get data from the shop floor to the top floor, so that if your bearing is wearing and it's causing more current draw, so your drive is going to let someone know. Now, none of that is wildly new, but the way it's going to get used is going to change in terms, and we'll talk about this more later, but it's going to supply more transparency up and down the food chain, within the plant, within the line, and all that kind of thing. So, and in particular, what seems to be a key part of this is not just using kind of the standard components, but really putting the emphasis on sensors, so that much of this is about information getting passed around in order to maximize resource use. And according to our IHS guys, by 2025, they see 5.4 billion, that is billion, that is not million, industrial IoT devices shipped per year for a total installed base of 48.2. 4.5 billion. That's a lot of billions, boys and girls. Let's see, next slide, please. And the point of all of it is, again, what you can do with information. I've been doing a lot. I do the articles for the Motion Control Association website. I've been writing a lot the last 6 months or so about how some of the smart components and options for better equipment usage and better performance, predictive maintenance, all that sort of thing. And again, having the connectivity means you not only get the information from the smart components, you can get it where it needs to go. So you can maximize the efficiency of your line. You can catch problems before they start. You can stop wear so that you don't get any artificial aging. But it's also having the visibility into your supply chain, so that you know what it is that you need to build stuff if you wind up having a plant go down or whatever, or not a plant, a line go down. Maybe you don't need as much material coming in. If you have better transparency into demand, you don't need to have massive amounts of inventory. It's being able to track all of this stuff and just leveraging that information. And as well, this kind of intelligence allows much more flexibility, easier changeover, so that you can personalize things much more easily. And that's ever more the trend of the way that the consumer is looking. They want to have what they want. They don't want to have what you want to sell them. And above all of this is finding ways to reduce costs so that people are happier and they buy more, and all is good. So anyway, next slide, please. Now there are several groups underway who are all working together to try to bring this about. As you might imagine, these kinds of efforts are challenging because the core of all of this, as I keep mentioning, is the connectivity. That means everything's got to play nice together. You've got to have a common protocol. You've got to have machines that can work with one another. And that's not an effort that can be done successfully in-house and proprietary. It really needs to be broad-based. So there are a number of groups underway working with the Industry 4.0 over in Germany. That's the German government initiative. A couple of companies, Siemens and Bosch in particular, are very much behind it. There's the Smart Manufacturing Leadership Coalition. There's the Industrial Internet Consortium. That last in particular also about just test beds and applications and kind of teaming up to do demonstrations, try to figure out how to make all of this work, and also do some of the groundwork so that it's an easier kind of adoption curve for users. And it's a kind of effort that's going to take off slowly, but these organizations are doing a lot of the groundwork. And I'm going to be putting together, after the webcast, a resources page. If people want to email me after we're done, I'm happy to email it back out, but just with links to all these groups and a couple of useful papers that I've come across in my travels that might be of interest to readers. So anyway, next slide, please. And just because I thought it was kind of interesting, if you're not aware of the kind of genesis of the whole Industry 4.0 lingo, the thinking is that Industry 1.0 was the Industrial Revolution, which was your 1780s steam engine, really the start of it all. Arguably, you could say Industry 2.0 is the 1870s, when mass production started to get rolling. People kind of had more facility and knowledge about food preservation, so you had production lines. Industry 3.0 was when we hit the 1970s. You started getting digital going on. PLCs drove advances in automation so that, again, you had a much higher level of economies of scale. And then the thinking is that the Industrial Internet of Things, with the connectivity, with the transparency, the information that it brings to manufacturers, that's going to take us through a new revolution and bring a lot more value, and that's why they're calling it Industry 4.0. Next one. So around about now, you're probably listening to all of this going, yeah, I know this. Certainly none of this is wildly new. Smart components, we've been yapping about those for the last 10 years pretty much. Smart drives, smart controllers, encoders, resolvers. And did I do a typo? That is not supposed to be a shattered DC bus. It's supposed to be a shared DC bus. Again, having that connectivity, having the shared resources and so on, you can get better performance. The key thing that's going on here, though, is it's not just the smart components, which are useful locally. They do a great job, and they can send a lot of information within the machine and so on. But the idea is taking those to the next level, so you get that broader continuity and connectivity you're able to share. So if, for example, if you've got a drive and you get a fault, normally it would notify the operator through the HMI, or a light would go off or something. Increasingly of late with the smart drives and Ethernet on your machines, maybe you're able to have the machine note it throughout the machine. More recently here, you've been able to let the whole line know, and some of the kind of interesting stuff that I've been hearing about over about the last 6 months is, hey, you know what? If I've got a fault on my drive and that axis is down, and I don't know, maybe it's a packaging line with converting on one end. So I let the intake end know to slow down so that it's not shoving boxes at me too fast while I'm still trying to get product ready to stick in the boxes. I let the other end of the line know that that part of the process is going to have to wait a few minutes before it gets more product. Meanwhile, while everybody else is slowing down, some of the smart components that are going to make it easier to do a safe recover, maybe safe jog or safe torque off or safe position, not safe position, safe speed, that gets taken so you don't actually have to take down the whole line, which can be really time-consuming sometimes. You've got to reset and restart everything and rehome. You're using that intelligence and, more important, the communication to optimize what the line's doing. And that's been going on here more recently. Also, the drive can notify maintenance, shop floor, top floor, can notify up top that, hey, our productivity is going to be down or our output's going to be down. But then it starts really getting slick when it's able to let other parts of the plant floor know, and even other facilities. If you've got something going on where you've got one plant feeding another, and that plant goes down for a couple of days, sure, the manager can get on the phone and make calls and talk to suppliers and either tell them they don't need raw materials or tell their internal or external customers, hey, you're not going to get your stuff for a little while longer. But how nice is it going to be if the system is doing that automatically? So all of this stuff gets taken care of because of the connectivity. You don't have to actually have people involved. They're spending their time trying to get stuff back up and running and take care of the problem. And the whole supply chain up and down is able to leverage the additional information. So that's kind of the way people are thinking about using all of this. Next slide, please. And this is a little bit more process than motion control, but it's still a really cool thing. There is a mining organization, and I believe this is a mine down in Australia. And as you can see, they got these big old hanging dump trucks, and these things whistle around, 30, 40 miles an hour hauling. And they used to have people driving them individually, but especially at night, they said, it's such repetitious work. It's like crop dusting, and people would fall asleep or just, lose attention, and these are pretty catastrophically large vehicles. So they decided to make them autonomous and put the operators inside a control room monitoring them on screens. So each one of these trucks is fitted with 192 sensors. They've got them on the engines, they've got them on the wheels, they've got them on the differentials. They're tracking everything that's going on with these trucks. They, speed, location. They are able to figure out exactly what route the trucks are taking from point to point so that they can minimize the distance traveled and minimize fuel consumption. They're able to look for heat, for wear, for worn bearings, for changes in tire pressure, pretty much anything that's going to interfere with operations. The people who used to be out there driving around and nodding off are now in a central processing area. They're still driving, but they're doing it remotely, and they're tracking all the sensors. And they've got 900 of these dump trucks doing this, and they also produce 4.9 terabytes. That's terabytes of data per day, which is something we'll talk about a little later. That's kind of scary, but it's a pretty amazing operation. On the resource page that I'll send out to anyone who wants it, or you can look on YouTube, do a search on Rio Tinto because they've got a video of this thing, and it's pretty amazing. They also have what looks like just a giant backhoe where it's just, dragging a scraper along the ground. And then as a scale thing, you realize that that scraper, like 12 people can sit in it side by side. So just the scale on these things is pretty amazing. Anyway, next slide. But what they get out of this is they've got more controlled operation. They're optimizing speed. Again, they're ensuring safety, getting the best fuel efficiency. They're getting predictive, not preventative, but predictive maintenance. They're maximizing the lifetime of their equipment and getting the maximum performance out of the mine. So a lot of benefits. All right, let's see. So on the downside, both of the analysts I talked to said, that had to cost them hundreds of millions of dollars. It's not cheap. And right now, it's not something that, every company out there can do. It's really bigger, more established companies that are going to be in a position to make these kinds of investments to really accrue the benefit. But that said, that's where the current fascination with the consumer Internet of Things is going to be really important. It's basically a variant on the way PC processor development and embedded technology for the consumer electronic space has benefited motion control right along, because all of that stuff gets developed over time. Prices drop, technology improve, critical dimensions drop. And you're going to see the same thing over here. It's going to get cheaper. You're going to transfer the technology. The other thing is, it is going to happen because the benefits out there are too large. So it's something where companies really need to take a good look at the possibilities, try to figure out how they can leverage the technology, and maybe stepping into it slowly, but it's something you really need to give good, solid thought to. Next slide. But, of course, none of these things are easy, are they? The biggest challenge for a connectivity-based effort is the communications side of things. Now, you may have heard here recently about kind of a big change with the Internet. We've been on IP version, Internet Protocol version 4 for a while, but that is set up for only a set number of Internet names and addresses, and they were running out, so they just upgraded to IPv6. So that is now the protocol that's going to be used for everything going forward. It's got a lot of advantages, actually, quite aside from, I think, something I saw suggested it corresponds to like 28 million IP addresses per person alive on the planet right now. So I think we'll be okay for a while, although certainly of all these big, scary numbers, we may need to go to IP7 soon. But it's got hierarchical addressing that actually makes it much more effective at routing. It's got somewhat longer header numbers or header lengths, address lengths, but ultimately it makes it easier to get packets where they're going. Less configuration to do, and it's also got a low power or broadband extension that might make it easier for these applications. But it's very important that anything that gets done, going forward, obviously has to be IPv6. Now, something I had hoped to be able to discuss in this webcast, and I really couldn't get the information that I needed, was to see how the kind of key industrial Ethernet protocols are set up to play nice with this or not. My understanding is that Ethernet IP is, kind of making a nice transition. I couldn't find out about some of the others. That's something I'm hoping to cover this summer. I'm doing a machine-to-machine article, and I'm hoping to be able to address this topic then, if not subsequent. So keep an eye out. When I know more, you will know more as well. Anyway, next slide, please. So the other thing is bandwidth. talking about machines festooned with sensors. All of this stuff is going to be easier on greenfield builds. But that said, as time goes on, it's going to become increasingly necessary to retrofit, because machine assets, those guys are built to last for decades at a crack. Now, the electronics, they might get swapped out every decade, but your machine base, a lot of cases, those guys stay around for 20, 30, 40 years. So there's going to be work being done there within the factory. There's going to have to be upgrades. So if you find yourself upgrading to try to get all this functionality, you darn well are going to want to be sure that your network infrastructure is going to be able to handle the bandwidth, because otherwise you're going to put all the money into it and then find out that you can't actually get there because your network is your limiting factor. The military did something called the airborne laser in the 90s, and actually here in the more recent decade. And the idea was to put a petawatt laser on a jumbo jet and fly it around to shoot missiles out of the sky. And the problem was they did this great job, built this laser in the lab. Yay, we got petawatt action going. And then they tried to put it on the jumbo jet, and they realized that all the cabling weighed so much that they actually had to rebuild a reinforced jet with better engines so it could get off the ground. And it's sort of similar to this. I mean, you can, if you're not careful, this stuff takes planning. You can't just jump into it, because if you're not careful, you can get everything going just fabulously on the machine, and you've got sensors to die for, but you don't have the bandwidth to make everything run. It's not going to do you any good, so keep an eye out for it. Next slide, please. And part of it is really being strategic through and through. And another typo, connectivity, that should say, not conductivity. You need that connectivity, and in theory you can connect everything, and certainly when you're hearing or reading articles about the industrial Internet of Things, they say, oh yes, it's not connecting one thing, it's connecting everything, but you can go too far as well. Just because you can connect devices doesn't necessarily mean you need to, or that it's in your best interest, because if you connect it without a plan, you don't know what you're going to do with the data. There's no point in getting it done, and then you're, again, you're bogging down your network, and you're not actually getting anything useful out of it. So strategy here is absolutely critical. Next slide. Another issue, of course, is security. I mean, that's and that always makes me roll my eyes a little bit when you hear about all the, ooh, hurrah, we can have our thermostats, and we can have our smoke detectors, and we can watch the kids come home, we can take care of the lights. Well, what happens if the bad guys hack into your network, and all of a sudden they turn off your lights, they turn off your security system, and they waltz on in? So, that is the danger and the risk with everything going online. You've got to have an absolutely rock-solid security. Now, I don't show you. You can't read it at the bottom very well, but Information Week and Rockwell did a study, I want to say in 2014, and the result was that less than 14% of manufacturing facilities said that they connected their shop floor to top floor because they didn't want the security risk. Now, when I was first covering this space, I think it was back around 2007, I was talking with people about Ethernet, web-connected machines, and so on. There were a lot of people saying, I don't want any part of it, or integrators saying, what I tell them is unplug it. You can leave it unplugged. If you have a problem, you can always plug it back in, and we can go run it. And as time has gone on, I think asset owners have gotten increasingly comfortable with not having to unplug that. And it really comes down to best practices. Next slide, please. yeah, well, then there's this too, though. Best practices are important because in a lot of cases in the kind of early time with the internet, devices have been put online, web access, yay, we have web server and all that, but there's a program you can look up called Showdown that they put together to start trying to track some of these assets. And this guy discovered all kinds of things accessible, totally open for a skilled user. Water treatment plants, a cyclotron, of all things. You could get on, hack into a cyclotron, hack into a dam in France. So you've got to approach all of this with caution because there are skilled people out there. Next line. So, you've got to, I was reading something the other day about how hackers do as far as protection goes. So organizations have to be thinking of this first. And again, this comes back to what I was saying earlier. Have a strategy, have a plan. You've got to think up front when you get excited about doing this. The next question has to be, how am I going to protect it? And the other thing is that's always come through anytime I've talked with people about security is it's not just the technology and the software. You've got to go about it in kind of a measured and focused way. You've got to have a plan. You've got to establish policies. You've got to ensure it that people are following them. I mean, you can have the best security in the world if your operators are scribbling down passwords or sensitive information on Post-its that they stick on the HMI, and you better believe they do it. You're only as protected as your staff and your staff training is. So, next slide, please. And another really important thing here, and I alluded to this a little bit earlier, is data. You've got all these connected devices, all this connected data. Remember our friends at Rio Tinto. When the mid-90s, I think, there was a technology that was starting to get a lot of play as an Earth sensing technology called hyperspectral imaging. And it's gotten actually some application here lately in the industrial sphere. But at the time, what they were doing was, imaging the Earth's surface from airplanes across, 1 by 3 foot spatial swatches and across something like, 200 spectral channels. Couldn't really deal with it very well, and they talked to the researchers. And they say, yeah, we got all this data, but we, it's a haystack, and we're trying to find a needle, and we have no idea how to get there because there's so much information. When you're looking at, filling up a factory floor with sensors and stuff, yeah, you got tons of information, but how are you actually going to use it? When you're spending money on that, you're spending money on your sensors, you're spending money on your network and your connectivity. You better know why you're doing it before you start doing it. And then you need to figure out how to handle it, because if you're gathering and saving data, you've got to have memory to stick it in. You've got to have processing power. If you're saving it, somebody's got to maintain it. Somebody's got to be scrubbing it, unless you've got a pretty impressive set of infrastructure. That's not something that's easily dealt with. So yeah, you want to know why you're gathering the data, how you're going to use it, etc. It's not, if you build it, they will come. The other thing to keep in mind with the huge data sets, I mean, a lot of talk these days about big data, and certainly it's got high levels of functionality for anybody out there that's not aware of it. Basically, it's techniques for taming uber large data sets, being able to do analysis, but also just even structurally being able to handle it. You use Hadoop to break it all apart and do a lot of parallel processing. Typically, you've got to know Linux because that's what Hadoop runs on. With a lot of the big data, they've got analytical techniques that let it deal with structured and unstructured data. It's all really powerful stuff, but you've got to know what you're doing. And if you're a small organization, it's going to be hard to take advantage of that much data because you've got to have pretty big processors. You've got to be doing power system servers type thing from IBM that can do massive amounts. You've got to have the security. Again, you've got to have the skill sets. I mean, you're getting 4 some odd terabytes of data a day. You better find out a way to understand why you're gathering and what you plan to do with it, or else you're just wasting a lot of time and resources. So, end of term. Next slide, please. So the key thing here, and it should go without saying, but I won't let it do that. You've got to plan ahead of time. If you're going to come in and do one of these, you need to establish your project scope and figure out what your network backbone needs to be before you start buying and installing all the sensors. Very important, you need to have that security strategy. You need to know up front before you ever get putting assets online how you're going to protect them. And also, are you going to protect them in a way that lets the data move quickly enough to accomplish your goals? Because that's the other thing, as we've all known, you can sit there and tap your fingers forever on firewall as things get slowed down. It's got to be practical. You've got to build out your infrastructure. You've got to have enough bandwidth. You've got to know how to use that data, what you're going to do with it and why. And then you've got to figure out a way to turn it from data into something that's actually usable. And that's talked about a lot in the business analytics side of things. I do some writing for IBM magazines, and there's a constant discussion there. How do you convert data into something meaningful that you can use not just to make decisions, but to gain insights from, and do it in some kind of a reasonably efficient time frame? And if you can do all of that, then you've got information that you can start applying, up the food chain like we talked about. Next slide. Rockwell wanted to test this out and see what happened. So they had 20 plants across the globe, and basically fitted them out with the intelligence, the connectivity, and so on over the course of 5 years. They put together their launch team. They figured it all out. They got the stakeholders in place so that everybody was communicating up front. Next slide. And the results that they came up with is on a plant-wide basis. Their inventory on hand, year 1 it was 120 days. By year 5 it dropped down to 82 days. Their productivity rose. On the customer-facing side, what they call time to want, which is their metric for on-time delivery, that rose from 82% to 98%. They cut rejects by about half on a parts per million basis. On the supply chain, because of the additional transparency that they had and visibility into operations, they were able to cut on-time supplier deliveries from mid-80 to 96%, and they also cut their lead time in half. So better utilization of resources, happier customers, less money sitting around in inventory and materials. It's kind of a direct example of what connectivity can do for you and what this industrial Internet of Things can do for you if it's done right. Next slide. So given all that, you're probably wondering, as I was when I It's very much in the early days. In some ways, we've just come up off of this recession. There's been a limited amount of capital expenditure. You're also talking in a lot of cases about risk-averse set of industries. There's a lot of investment involved there, and in some ways people want to keep it simple if they don't have to, if they're not buying a new machine. Let's stick with what we've got. And the other side is, I put up, like we've been talking about, I put all this in, how do I get value out of it? I think some of those numbers we were talking about with these guys in Rio Tinto, so there's value out there, but it's still a leap. Next slide. Not surprisingly, our early birds out there are the usual suspects. That's your oil and gas, your food and beverage, your pharmaceutical. Those are all industries that historically are kind of on the cutting edge. On the upside, along with the consumer Internet of Things, those guys are going to kind of take it all through the growing pains. So companies sitting on the sidelines are going to be able to benefit. On the downside, though, the later you get in, the less of an opportunity you have to really get a competitive advantage out of it. So it's something manufacturers out there really need to start thinking about now and kind of evolving a strategy, even if they don't get off the sidelines immediately. It's something they need to think about because it's going to have a big long-term impact on their performance and the performance of their competitors. Next slide. And in the spirit of telling what you told them, as I think some numbers showed, there is potential for huge value. Obviously, GE certainly thinks so. But you got to do it right. You got to know what you're doing. You got to know why. You got to have a strategy in place, top to bottom, so that you are thinking in terms of infrastructure. You're thinking in terms of security. All of that stuff is taken care of before you ever start actually putting in all the sensor components. And as much as it's exciting to think about connecting everything, focus on where you're going to get value. Numbers and turn them into something useful, and then once you do, also figure out how you actually expect to use it in a way that's going to fulfill a business need. And as I mentioned earlier, I am in the process of putting together a resource page. Next slide, please, Carrie. So anybody who is interested in getting that resource page, if you could shoot me an email, and I can make sure you get a copy of it. Also, if you have any questions, I think we're running a little short of time. If you have any questions, you can also email me, and I will certainly get back to you as soon as possible. And other than that, thanks very much for your time. Hope you found it interesting. Carrie, I will turn it back over to you.
Thanks, Kristen, for that presentation, and thank you to all the participants today. I just want to remind everyone that this webinar has been recorded, and an email with a link to the recording will be sent to you within the next 24 hours. If you have questions on the presentation material, please feel free to email Kristen or myself, and also be sure to visit motioncontrolonline.org for a list of our upcoming webinars. Our next webinar takes place on Tuesday, February 9th. That's on DC motor types and usage in typical applications. And I'm sorry, that's actually Tuesday, February 3rd next week. So thank you, everyone, and have a great day.